Okay, so if we have 6 over 2 plus 8i, 2 plus 8i is the complex number. We can't have an imaginary in the denominator. It's against the rules. So we've got to multiply by 1, because 1 can multiply to anything and not change it. But we want to multiply by 1 that's in the form of what we call the complex conjugate. It's where we write this whole thing, not changing the first one, but only changing the symbol in the middle. 2 minus 8i. Okay, so that's our denominator half of the complex conjugate. And we write the exact same thing on top. Don't change anything. Whatever is on the bottom has to match what's on the top. That's called the complex conjugate. If they're not exactly the same, it doesn't equal 1, and it changes everything we're doing. What we're going to do is we're going to do all this multiplication to get the I off the denominator, but it will actually be the exact same problem, just written in a different format. So now we've got to do the multiplication. So we're doing 2 plus 8i times 2 minus 8i. There's what we're going to use is FOIL, first, outer, inner, last. We take the two firsts and multiply them together. 2 times 2, that equals 4. Then if you look at the whole picture of this, the 2 on the outside, right here of the picture, that's our outer, 2 times negative 8i. So we have 2 times negative 8i. With that, we just multiply the 2 and the negative 8. That's negative 16, and bring the I over. Okay, then we're going to do the inside for the I part, inner. So if you look at the whole picture, we're going to look at the 2 inside numbers. That's the 8i times the 2. 8i times 2. 8 times 2 is 16, and then the I. And then the 2 lasts. For our L is last. The 2 numbers at the end of each pod. 8i times negative 8i. 8i times negative 8i. And that gives us negative 64i squared. Your students should instantly, when they see an I squared, go, wait a minute. I squared cancels out and changes the sign of the number it's with, because I squared equals negative 1. Negative 1 times negative 64 makes a positive 64. Most of the students got that pretty quickly. So now I'm going to add all of these together, combining like terms. So we have, I'm going to come down here, 4 plus negative 16i plus 16i plus 64. I'm going to put them in order based on like terms. So I have 4 plus 64 plus negative 16i plus 16i. Adding the two like terms together, 4 plus 64 is 68. And then negative 16i plus 16i, that equals 0. If I have 16 horses and someone takes away 16 of my horses, I now have 0 horses, just 0. So that's 0. 68 plus 0 is just 68. And that's our denominator. I'm going to come up here and I'm going to write over 68. Now I've got to do the top. It's distributive property. It's going to be 6 times 2 is 12. And then it's going to be 6 times negative 8i. So 6 times negative 8i. 6 times negative 8 is negative 48i. So this just hangs out together on the numerator. I'm going to bring it down here so it's all together. 12 minus 48i. This actually can be reduced because everything's divisible by 2, but if your student gets it to this, they will get full credit in my class right now. That's what I'm looking for. The formal writing of it would be reduced and then split out. Let's see, 12 over 68. Let me see what that is. Let's see, fraction over fraction. I'm going to do 12 over 68, and it should give me a fraction 3 over 17. So I've reduced So you give the 68 to both of these. So it's 12 over 68 minus 48 over 68i. 12 over 68 is equivalent to 3 over 17 minus, come down here and plug it in my handy dandy box over here, 48 over 68. That gives me 12 over 17. So 12 over 17i. And this is a complex number that is totally equivalent to this complex number. They are the same thing, but this one has no I in the denominator, which is what we need. So we're just converting to get the I off the denominator. This should really help you with the first several problems, the ones that have just one number here.